Let's prep for the graphs of logarithmic functions by actually looking at the graph of a logarithmic function. And to do that, let's fill out the table of values for the function f of x equals to log base 2 of x. So the base of this logarithm is 2. So first let's say when x is 1, what is the value of the function? Now remember, this is saying, okay, what is log base 2 of 1? So it's asking 2 to what power will give me 1? Well, 2 to the 0th power will give me 1. And log base 2 of 2, that's saying 2 to what power will give me 2? 2 to the first power will give me 2. And doing this for the rest, log base 2 of 4, 2 to the second is 4. And then log base 2 of 8, 2 to what power gives me 8? 2 to the third power gives me 8. Now let's plug in some values close to 0, but still powers of 2. So log base 2 of 1/2. 2 to what power will give me 1/2? Well, 2 to the negative 1 power would give me 1/2. And then if we had log base 2 of 1/4, 2 to the negative 2 will give me 1/4. And log base 2 of 1/8, well, 2 to the negative 3 will give me 1/8. Now, what about log base 2 of 0? Well, 2 to what power gives me 0? This does not exist because 2 to no power will give me 0. So if you plug that into your calculator, you'd get an error message. Same thing that if I raise 2 to any power, either positive, negative, fractional, whatever, 2 to any power is a positive number, so you can't get -1 from 2 to any power, so you can't plug in -1 into the logarithmic function. So just a rough sketch of plotting some points. So we have the point 1, 0, 2, 1, 4, 2, 8, let's see, 5, 6, 7, 8, 8, 3. So from here you see it's increasing, but it's going to increase really slowly because to get to 4, we now got to go all the way to 16. To get to 5, we got to go all the way to 32. Now, when x is 1/2, it's -1. When x is 1/4, -2. So what happens as you get closer and closer to 0 for x, the y values get more and more larger negative values. Now let's actually look at a better graph of this function. So in blue is the one we just graphed. What was that? Log base 2 of x. Now, what about the inverse of this function? What about the graph of 2 to the x? That's the one we have in red here. Now, remember that these are inverse functions of each other that, let's say again, we know when x is 0, when x is 1, y is 0 for the logarithmic function, and we have the point when x is 0, y is 1 for its inverse on the red graph. And then when x is 2, y was 1. And then on the inverse, when x is 1, y is 2. And then when x is, let's say, 4, y is 2 on the logarithmic graph. So that's saying when x is 2, y would be 4 for the graph of the 2 to the x functions. So again, when you're dealing with inverse functions, that the way the graphs are related to each other, like point-wise, is that the x and y coordinates are switched, which means that the reflections about the line y equals to x, which is this green line. So if you were to reflect the graph of the logarithmic function about the line y equals to x, you get the exponential function and vice versa.